Hey guys, before we start our notes for today, I want to go over this practice R1.1 from last week. I kept seeing a lot of common mistakes, so I just want to go over them to help clear up any misconceptions that you may have or any problems. I know it's hard because I'm not in class with you, so if you have questions, it's harder to get a hold of me. But I appreciate y'all's hard work, and I just want y'all to keep trying, okay? You are able to go back in and correct this if you want to. Some of y'all need to. Once I have graded it, you should be able to see your grade. You can click back on that Google Slide assignment and go back in and read the comments that I left for you. Also, I highlighted the problems that were wrong in red. So if you want to correct it, you can do your corrections in a different color or submit them to me in a private comment. Just make sure that you hit resubmit back on your Google class assignment. Okay, let's go to number 4 because a lot of y'all missed this one. I'm going to go ahead and circle these terms. I think we're a little confused on what a term actually is. Okay, anytime something's multiplied all together, like on number 2, everything's being multiplied together, so that's one term. So this should have been a monomial, which most of you got. But on number 4, every time I have a plus sign or a minus sign, that's going to separate a term because I'm no longer multiplying it all together. So my first term is negative 3w to the 4th. My second term would be w squared. My third term would be negative 9x. And then my last term is 5. So really I have 4 terms here, and we don't have a name for that. So that's why in the instructions it lists other. I think somebody tried to name this like a quadnomial. And that might actually be correct. I'm not sure. So you can take like quadnomial or just other. All right, now for the degree. We are looking at the highest exponent. So the highest exponent of each term is 4. You don't have to add all the exponents together because these are not one term. There's 4 different terms here. So the highest exponent of all of the terms would just be 4. Okay, let's come down here and look at number 11, because this one a lot of people missed. So this is a monomial because everything's being multiplied together. It's just one term. And since it's a monomial, in order to find the degree, we have to look at all of the exponents. And we've got 2 exponents here. I have an x to the first power. Remember that 1 is there even though it's invisible. And then a y to the second power. So if you only have a monomial, in order to find the degree of it, you have to add up your terms. So I would add 1 plus 2 to get a degree of 3. I know that one's a little confusing. Same thing with number 8. Because this is a monomial, and to have more than one variable, I have to add up all the exponents. So this is 2 to the x squared, y to the first power, and z to the third power. So I need to add up 2 plus 1 plus 3, which would give me a degree of 6. You only do that whenever you have more than one variable in a term. Okay, so now let's go to the next page. I want to look at number 14. We have to make sure that we're subtracting each term in the parentheses. A lot of you subtracted the 2x, but did not subtract the negative 2. So I'm going to start with 3x plus 1. And then I'm subtracting the 2x and then subtracting the negative 2. So really what happens is this turns into minus negative 2, so it becomes a positive 2. Okay, you have to distribute out that subtraction to each one of those terms. Now I just need to combine my like terms. So I'm just combining what I have in common. So I've got my x's that are the same unit. So 3x plus negative 2 would be 1x. And then I've got positive 1 and positive 2, so I can add those 2 together to get 3. Okay, let's look at another one that was commonly missed. Number 19. First off, you have to distribute or multiply each term by 4.2. So 4.2 times 5 is 21, and that would be 21x since it was 5x. And then 4.2 times negative 1 would be negative 4.2. Make sure you pay attention to your positive and negative signs. Now we need to distribute out negative 3.4. So we're multiplying everything by negative 3.4. So 7 times negative 3.4 is negative 23.8x. And then negative 3.4 times negative 3 is 10.2. So it's positive, so I would add it to be plus 10.2. Now I just need to combine my like terms. So I need to combine all my x's together and then just all my numbers together. So let's start with the x's. I've got 21x minus 23.8x. And 21 minus 23.8 is negative 2.8x. Now I can combine my numbers. Negative 4.2 plus 10.2 would equal positive 6. So a lot of y'all were starting off correctly, but you might have missed a negative sign or you may have added incorrectly. So just make sure you go really slow and pay attention to all of your signs whenever you're working these out. Alright, now go ahead and get out your unit title page and we will start the notes for today. Today's lesson is 1.4 and we're still multiplying binomials, but this is going to be special cases. So I'm just going to write special cases because I don't have enough room to write all of that. Then go ahead and turn to your first page of notes. We have worked with multiplying binomials, but we're going to look at some special cases. So let's go ahead and multiply out number 1. You can do the distributive method or the box method. So x times x would give you x squared. X times negative 3 is negative 3x. 3 times x is 3x. And then 3 times negative 3 is negative 9. So whenever you combine your like terms, what happens to the middle term, the x terms? I've got a negative 3x and a positive 3x. Well, they should cancel. So I would just be left with x squared minus 9. Alright, let's do the next one and see what happens on that one as well. So I've got 2x times 2x, which would be 4x squared. And if you want to draw the box, go ahead and do the box too. That's fine. 2x times 5 is 10x. Negative 5 times 2x is negative 10x. And then negative 5 times positive 5 would be negative 25. So once again, our middle terms cancel. 10x minus 10x is 0, so it's eliminated. I would just be left with 4x squared minus 25. So looking at both of these examples, just take a couple of seconds and think about what do you notice about the factors. So the factors are the actual binomials. So like x plus 3, x minus 3, and then 2x minus 5 and 2x plus 5. You should see that they're opposite. So in number 1, I have x plus 3, and then I have the opposite binomial, x minus 3. Same thing on number 2, I've got 2x minus 5 times 2x plus 5. So the signs are opposite. Okay, now let's take a look at the product. So the product is actually what I have squared, the x squared minus 9, and then the 4x minus 25. Well, one thing you should notice is that the middle term is eliminated. Let's also take a look at the numbers of each term in the product. So on number 1, my final answer is x squared minus 9. And then on number 2, my final answer is 4x squared minus 25. So going from the original polynomials, let me circle that in yellow. What happens is we end up squaring both of the terms in the binomial. So I'm going to square the first term, which is x, and x squared is x squared. And then I'm going to square the 3. So 3 squared is 9. Same thing over here. I'm going to square the 2x to get 4x squared, and then square the 5 to get 25. So this is why this rule is called the difference of squares, because anytime you multiply two binomials where their signs are opposite, you're going to get a difference of squares. So that rule is, if I have one binomial a plus b times the opposite a minus b, my product is going to be a squared minus b squared. So basically all you're doing is just squaring the first term and then squaring the last term and then subtracting them. It's always going to be a minus sign, and that's what's called a difference of squares. Okay, so now let's look at these two problems. So now I've got x plus 4 squared. So let's go ahead and multiply this out. One of the most common mistakes I see is kids try to just distribute out this exponent, and we cannot do that because this is a binomial. X plus 4 squared is really x plus 4 times x plus 4. Because I'm raising that whole binomial to the second power, that means I've got two of them. So now we could go ahead and multiply this out. So x times x would give me x squared. X times 4 is 4x. 4 times x is 4x. And then 4 times 4 is 16. So now let's combine our like terms. I've got 1x squared. Then I have 4x plus 4x, which is 8x, and then 16. So with this problem, we didn't eliminate our middle term. Okay, let's see what happens on the next one. So same thing, I need to rewrite this as 2x minus 3 times 2x minus 3. Because I'm squaring it, which means that there's two of them. So we're going to multiply it out. 2x times 2x would give us 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. And then the last terms, negative 3 times negative 3 would give us positive 9. So let's simplify this. Negative 6 minus 6 would be negative 12. So I'd have 4x squared minus 12x plus 9. So this time I want you to take a couple seconds again and take a look at the binomials. So what do you notice about the factors, or the binomial themselves? We had x plus 4 squared, and then 2x minus 3 squared. Well, we were multiplying them by the same binomial, because anytime you square something, you're multiplying it by itself. So the factors, or the binomials, would be the same. What do you notice about the product? So let's take a look at number 3. For my final answer, I got an x squared, which came from this x in the original problem. So I had x became x squared, and then I got 4 from my last term, and my last term in my answer is 16. So I squared the x and I squared the 4, But how did we come up with 8x in the middle? Well, what happened is we ended up adding 4x and 4x together to get that. So down here, we have what's called a perfect square trinomial. Let's go ahead and write out what that rule is. Anytime you multiply like a plus b and you square it, so you're multiplying it by itself, you're going to square the first term, so square the a. Then you're going to multiply the a and b together and double it, because there would be two of them. And then you're going to square the last term, which would be b. So let's see if we could have done that problem a little bit quicker using this rule. So down here in green, I'm going to do it. So this would have been x plus 4 squared. And instead of multiplying it out, I'm just going to use this rule. So I would square the first term, x squared. Then I would multiply the first and last term together and double it. So I would multiply x times 4, which is 4x, and double it. So I would get 8x. And then I would just square the last term. So I'm going to square the 4. 4 squared is 16. So we get the exact same answer. So you can choose if you want to use this perfect square trinomials rule, or if you just want to multiply it out like what we've been doing. Either way, you're going to get the same answer. Okay, now let's look on the number 4 problem. I'm still squaring a binomial, but my operation is a subtraction sign. So I would have a minus b squared. What you're going to do is you're still going to square the first term, but since my binomial is being subtracted, I'm going to have minus 2ab. And then I still get a plus b squared on the end, because anytime you square something, whether it's positive or negative, it's going to turn out positive. So let's use this rule to resolve number 4 and figure out if we get the same answer. So I'm going to square the first term. My first term is 2x, so I have to square the 2 and the x. So 2x squared is 4x squared. And then to get my middle term, I need to multiply the first and last term together and then double it. So 2x times negative 3 is negative 6x, and then I would double it. So that would give me negative 12x. And then for the last term, I'm just going to square negative 3. So negative 3 squared is positive 9. So we get the exact same answer as what we did up at the top. So same thing, you can choose to use this rule if you think it's faster and you like that shortcut, or you can keep just multiplying it out like what we've been doing. I just want to introduce this to you because when we start factoring, you're going to have to remember these rules later on. Alright, you're going to do an iExcel. If you have any questions, let me know. Talk to you later.